Hi, everyone. So my name is Moti. I'm the product manager of the hierarchical Crosswork Controller, which is part of the Crosswork suite. I joined Cisco with the acquisition of Sedona. Sedona was a small startup that developed multi-layer IP and optical network orchestration, kind of an orchestration or controller. And I think a major use case of what we do now with the hierarchical controller is the automation for the routed optical network. So a few words about the routed optical network before we dive into the automation details are that when we look on the Trustment network today, then we know what are the components there and the technologies. We have the routers with the services with the MPLS VPN, layer 3 VPN, layer 2 VPN. And then we have the OTN switches with the coherent optics and the transponders, and then the ROADMs. And each system is normally with the different management systems or SDN controllers. And normally when we look on the operations, then it is being managed by different parts of the organization, like the IP department, the optical department, and then comes RON. And RON is all about changing the paradigm of this IP and optical network by, first of all, fully converge services. Like if we have the IP MPLS today, and then we have also the OTN services, or what was there, STM, SDH and Sonnet. Now with the RON, we're able to converge those services and also those that require high bandwidth and SLA into the same router gear. And then simplifying the architecture, meaning reducing the layers and the protocols, and that by having actually a DSP coherent transponder as a pluggable, ZR pluggable gets into the router and being connected from the router to the optical network, to the photonic network. And that means a lot of saving in a power and space, simplifying the operation, and actually on the same gear, on the same devices, routers, we're able to provide not only the IP MPLS services that we had so far, but also those that were traditionally the OTN services, the TDM services, now being able there with a solution that we call circuit style SR policy based on the segment routing. And on top of that, also the PLE services, private line emulation, which emulates the services that are on the optical gear and being able to provide on the same services on the same optical gear. Now comes the part of the automation, which is in the center of it, meaning that normally when I come back to the question of the separate parts in the organization, the IP and the optical, that solution creates a little bit of a problem for the organizations, because what we did is to take the optical transponder as a pluggable, puts it into the router. Now come many questions of what happened when there is a problem. Is that by the control of the IP group or the optical group? IP group, they don't have the knowledge of the optical. They don't know how to handle all the configuration there, troubleshooting, etc. What happened when there is a software upgrade to the router? Who's responsible now for the shutdown of the wavelength from the router to the optical network? So many questions there that require some challenges, and that we come with the automation of the hierarchical controller, which means that we're able to connect not only to the routers, but also to the optical equipment. So if we look at this link up to now, then we know that this link is a link between the transponders to the ROADM managed by the optical vendor link management tool, which can be NMS or SDN controller. And what we do is that we put the HCO on top, meaning that there is still the optical vendor controller or NMS there controlling the ROADMs, but now the QDD pluggables, including, by the way, not only the transponder, but also amplifiers as pluggables into the router. Now they're all part of the routers. And now we have the ROADMs, the routers, the optical vendor controller, like, for example, can be Cisco ONC, it can be EPNM by Cisco, it can be Sienna MCP, Nokia NSP, all these SDN controllers for the optical equipment, any HCO on top. Now, when you look on the HCO, what you get is actually a full view of the link from the router side, including the services on the router, down to the optical side, starting from the ZR pluggables and into the ROADM. But before that, maybe a few words about what the hierarchical controller is, which we call the HCO. That's part of the standard that was developed in the last few years by ITF and by TAPI in order to cover the solution for the optical management, optical automation, and we managed to get into the hierarchical controller a full view of the network from the IP layer, meaning from the services, down to the fiber, and mapping all the layers starting from the IP VPN to the segment routing or RSVPT tunnels, the IP links, the links that the OTN line or Ethernet, down to the OCH, OMS, OTS, and even down to the fibers. So we're able now to provide customers with a full view and multi-layer view of all the network. And you can imagine what we can do with that. Like, for example, if there are questions of what happens if I take for maintenance one of the components in the optical network, which IP services will be impacted? How would I know if there is any alternative path to those services? So we're able to answer such what-if questions into the system. We're able to provision services over the network, starting from the IP layer to the optical layer. Also to do assurance and troubleshooting. This is a full solution for a transport IP and optical network. And specifically for the case of the routed optical network, then we come with a solution that was naturally part of the solution we achieved so far. To mention that we started to develop the solution back in the Sedona time, where we were on kind of a software independent vendor, and we had the privilege to be connected to many of the vendors, many of the optical vendors. We got their cooperation. Thanks, I would say, to the leading customers that we had back then, which were Vodafone Group. They have selected us as their hierarchical controller, and we started a process they called auto certification with all the vendors. Auto certification means that instead of doing the integration, normal OSS integration that were so far, now that we have standards like the TAPI by the ONF or the ITF, the ACTN by the ITF, and assuming that those standards will make the integration easier, what they have expected is that we, as a vendors of the hierarchical controller on top, will have integration with the optical vendors and the IP vendors independently, without them being involved. That they call auto certification. And thanks to that process, we have integrated with Ciena MCP, and Nokia NSP and Huawei NCET are now part of the process that we are running now. We connected, of course, to Cisco and to Juniper, and getting also, back in that days, also connectivity not only to the NMSs or SDN controllers, but also directly to devices. So we managed like Infinera, ADVA, Fujitsu, and almost all types of the optical devices that are in the market today. What we provide in the HCO, in the hierarchical controller, is a visualization, first of all the network. As I said before, we managed to cover also the fiber links that are part of the network, getting them as KML, KMZ files, because this is based on a Google Maps. So we're able to get the fibers, put them on a map, and on top of that map all the active layer. So we created kind of a subway view in the application. So when you look at the link, if you select the IP link here, the one that is colored blue here, then you can see the optical path used for this IP link being colored on the map, and you can see exactly where this optical path traversed to. And if there is any failure, you can see where the failure is. I have a demo which I would like to show you after that, and I think that explains a lot about.
Does that showing the failure include like, I want to say OTDR data, like you can detect it's a cut and where the cut might actually be?
Not yet. We had a demo of getting the OTDR file, results of the OTDR test file, and show that exactly where this is on the map. But I must admit that use case is not really was developed so far in the product. There were other use cases based on the fiber management that we had for one of the customers who would like to use the data that we have in order to detect some violation of proximity rules. Say, for example, if you detect there are two fibers that are in the close proximity of 25 feet from each other, then you can consider that as a violation, because that might be prone to single point of failure.
Yeah.
And you should report us to that. And that, thanks to that, we're able now to ingest this information into the provisioning system.
That's always been a concern of mine when I'm talking about, getting two paths to go someplace. It's like it doesn't, if they're in the same conduit, not redundant, because the conduit can get
exactly. So that would one of the use cases. That's a little bit, I think the solution is actually based on the fact that, first of all, we have the platform, meaning that that's what we consider kind of a golden data, because we have from the fiber to the service. Now comes many use cases to use that. Routed optical networks, of course, one of them. Identifying the violations of proximity rules is another one. Now, just fresh from today, I've met a customer now in the booth today, and when I showed them the map, then I drill down into the topology, like here, for example, and they say, why won't you give me a label that I can stick into it and say, this is a splicing there? I want to record that. I want us to know that, because that's an information that in your system will be very, very easy to attach there.
Yeah, because you're going to notice, somewhere along the line, any splice is not going to be perfect. You're going to notice loss because of
right.
Yeah. To know.
So I think considerably we see this system as young, meaning we're in the first steps in the industry today. There are deployments of I would say around 10 different deployments, but there are many use cases to come, and we see a full and quite challenging roadmap, I would say, for the product. So that comes the visualization part. Now for the back to the routed optical network, we have the link provisioning, which I think saves a lot of the headache around setting up the link between end-to-end between the routers with the QDD, because that means that we should go to the routers to configure the part of the ZR pluggables, and then understanding whether there is already a connectivity, like a CNM, or what's called in the standards the OTSI-MC connection between the ROADMs, whether this is configured or not. If this is configured, then we know there is a wavelength. We should read the wavelength from the ROADMs, set them up in the QDDs, and then set up also the IP connectivity end-to-end from the routers, and let the user see that everything is connected. So this is all being done automatically from the HCO, meaning we get the request, we set this up in the routers, we set it up in the ROADMs, and we just recently started integration with the vendors, because in most cases where we go, of course, the solution is that we bring up the routers and the QDDs, and ROADM networks are there by us, by Ciena, by Nokia, Huawei, whatever, and they have their own optical controllers to support that, and we started integration with them, which means that what we need from their controllers is actually, first of all, to support a provisioning of an alien wavelength from side to side, because from them, they don't see the transponder side. And then what we need from them is also to read the information on the power management, power measurement, I would say, on a wavelength granularity on the ROADM port facing the QDD. Because that what we use that is for a connectivity check. Because basically you can imagine that when we have to discover this network end-to-end, and when we look on this link, then there is no way for us to read any information. There is no packet base there, and no control plane, nothing that we can read and see that discover such a link. That means that we tell user, okay, let us know manually that there is a link there. And once you tell us that, we take randomly a wavelength in the ZR pluggable, and we play like a shot, no shot. We turn on and off the power in the ZR side, and then we read the power measurement, meaning the RX power, in the ROADM side. And then if you can see a match in the pattern of on and off cycles, then we know that the link is connected. Of course, when there is no traffic there, because otherwise it will be traffic affecting. And then comes also the troubleshooting part, which means that once we have those all links and all the layers, then as you can see here, we have it from the logical link and into the physical link between the routers. This is basically the router. These are the ROADMs, and then the amplifiers. And we read all the information there, and you can, as a user, go and click on each one of these components here, like on a port or on a link. You can see here the summary of the performance and also the history of the performance. And that gives you, one view, the different performance in a different technology. Like when it comes to the photonic layer, you can see the power level. When it comes to the ZR, you can see the bit error rate and the forwarding error correction, and the packet layer when it comes up. So it will be easier to detect any issue when you have and you don't know where the problem is, in which link, and what's the history of it. So that's the purpose of it. Few words about the architecture. How does it go? So I think I mentioned that verbally, but we can see it here. There are the domain controllers for each part of the network. This is basically the IP part, and there is a domain controller like Cisco Crosswork Network Controller, or the Nokia NSP, or the Juniper Paragon. They manage the IP gear, and then we have the optical controller for the optical line system, ROADMs, and the ZRs, and we do validate this analog crosslink by the on and off, playing on and off with the wavelength from the ZR side, reading the power in the other side. I would like to switch to a demo and show you a record of, I believe, a good view of how does it look like. So this is basically the first map that you see when you open the application. And as you can see here, these are the links. The blue links are the IP links, and these are the sites, physical sites that has IP devices and optical devices. And when you select a link, you can see all the layers here, starting from, for example, for this one, you can see a segment routing policy going to the IGP and to the physical link. And as you can see in the other part of it, it is being connected through a log, meaning a bundle, to all layers, like the ZR channel, ZR media, OCH, OMS, OTS, down to the fiber layer. And as you can see here, you can see the details of each one of the layers. And in a second, you can see how when we simulate a failure, you can easily see on the subway view here what happens when there is a failure detected in one of the links. Let's run that more quickly. Yeah, we've added here the picture of the equipment. So you can see here in this specific demo, there is the NCS2K device by Cisco as a ROADM connected to the ZR pluggable in the ROADM. So you can see here, this is the RON port in the NCS2K. Sorry, this is the NCS2K, and you can see that this is being connected here. Now there is a configuration change that let now the media channel going down, meaning to raise an alarm, to say something happened to the media channel, but the fiber is okay. The link beneath, like the OMS link, is okay. Now, what happened if we make this change? Let's see what happened to the link in the view. Yeah, that goes to the link assurance application, which is the same application I showed you the snapshot of it. And when I select a link, you can see it being covered, and to the layer of the OTS, the OCH. And when I select that, I can see the power, the summary of the power level in dB. And go to ZR media, I can see that for the pre-FEC bear, post-FEC bear, Q factor, Q margin, OSNR also is going to be added there. And that's a summary of it, meaning the current performance, and also in the performance tab, also the history over time that is being collected. It's the lowest layer of the OTS. I'd like to jump into showing you the failure here. Okay, then we see it. Now we can see it by the showing the alarm here on the chassis. And let's see what happened in the map when it's been identified. Yeah, as you can see here, links were colored. So a link down is colored. Now you can just drill down and see what is the lowest layer that the link is down. And as you can see here, the media channel is down because it was red, but the other links, the lower links, were up. So I know that problem is in the media channel. And it saves me a lot of time, because if I would see now a problem, kind of a degradation in service in the IP layer, the only chance is to look at that. And then after that comes the root cause analysis tool, meaning I can see that there is a root cause, there is an issue detected in the media channel, been placed in the table here. And when I select that, I can see what are the services and other layers that were impacted due to this failure. So I can see that there are router links that were impacted, and also there is an IGP link here. They all were impacted as a root cause of the media channel failure. And then we can, if you open the tool, then we can see it here. Like we can see all the layers that were down to the media channel, and all the OMS links are, OMS link in this case is up and running. And we keep record of all the changes, which is another feature that we have here. I think it wasn't recorded here. As you can see here, the banner, the green one, that allows you to actually apply a time machine, meaning you can see the network as it is now. What if you go back in time? So you can see what was the status of the network back in a certain point in time. So that really helpful when you would need to troubleshoot a problem and see all the consequences.
Where's the app getting the logs? Are the devices just streaming directly to the app?
No, we had that solution in the past where we connected directly to devices and using either streaming telemetry, syslog, or even sometimes even polling. But normally we go into connecting to SDN controllers and NMSs rather than going directly to devices, because we found out that when we were a small startup and we had to prove that we can do everything, like, okay, we can go to devices, give us whatever, CLI, SNMP, syslog, we can do everything. But when it comes to setting up a system in production and getting in scale, we connect only to NMSs and SDN controllers, because we find out that it's not sustainable to have a productized solution using CLI.
That's so many changes. Those are fireboxes in your diagrams, or the OHC. Is that what that was?
Yeah, exactly. So that was it about. Something interesting going in the market now. I think that's the end of the demo. Something interesting going in the market now with regards to the a solution for the ZR pluggables, because at the end you can imagine that not only Cisco has the ZR pluggables, also our competitors, and that raises a lot of questions, which are, I think, generally questions in terms of the disaggregated optical network, which is a very hot trend in the optical network, which means that you can potentially buy the ROADMs from one vendor and the transponders from another vendor, and then you can just put a system on top and manage that. But then comes questions of who will control this solution. So we, Cisco, believe that the best solution for that will be to have the hierarchical controller on top, because that gives us the ability not only to map the connectivity between the ZR pluggables to the ROADMs, but also all the layers on top. So having in one system from the layer 3 VPN or EVPN down to the fiber, which is very unique. And there are other trends in the market today to actually expand the capacity of the optical controller to the ZR pluggables. So some of our competitors, there are discussions, just to get a refresh indication now, there are discussions in the IETF forum about the solution for that. And they all agreed that the optical controller that manages the ROADMs should get access also to ZR pluggables. So getting the connectivity ZR pluggable end to end. And then there are some others that would like now to extend that to cover also the configuration of the ZR pluggables, not only the visualization, the reading part of it. But at the end, I think that when we look at that, I think the core value of getting really service to fiber is pretty much unique, and especially in a case where RON routed optical network is a lead use case, but there are way more than that. I think that we got now into several customers that would like mainly to use that as part of their automation dream. So when we talk to customers, for example, they look at that, and what they see is an opportunity for them to put kind of a workflow manager on top of the hierarchical controller, of the optical controller, the IP controllers. And normally what they want from us is not necessarily, I would say, the UI, even though the UI is very, very nice, very friendly, and they can do a lot of use with that. At the end, what they want is APIs. They don't need the UI. And the dream is give us APIs for everything you have here, connecting into their workflow management, so they can run solutions like, I think the hot one is a coordinated maintenance, meaning they want to coordinate the maintenance in optical network, taking off some of the components for software upgrade or repair, and they would like to make sure that that being scheduled, they know exactly what is the impact on the IP layer, and if needed, they can trigger the IP controller to do some reroute of the traffic from one path to another in order to complete the maintenance. So for that, they really see a solution in which they get into using our APIs for understanding which are the services that could potentially be impacted, go to the IP controller, make the change, and have an application on top that coordinate all this workflow, starting the maintenance session and terminating the maintenance session. So I think this is really where we are. I don't have much time to talk about that, but I think one of the key applications that we have here in the HCO is what we call SHQL, because you can imagine that when you look at the data that we have here, we have multi-dimension data. It means we have the multi-layer, and since we keep snapshots of the network with all the changes, we have also the time dimension. And that all being kept in a rational database. When you get into that rational database and you would like to ask questions like, what happened to which LSPs were impacted because of an OMS failure that failed 2 days ago? That's a really complex question to ask a rational database. And we developed an application on top, which is called SHQL, named after Sedona Hierarchical Query Language, to ask very simple questions in a very simple language. Unfortunately, I don't have it here to show you, and ask questions like, such as the one that I mentioned, and also using some keywords like downward and upward in a layer. So, for example, inventory, link, type LSP, downward to OMS, to OCH, and then I can ask questions like, I would like to know which OCHs are in the path of a specific LSP. It's a very simple question that I can ask, and if I add the time step, then I can let the system know that I want the information from a snapshot back in 2 or 3 days or a week. So we have a REST API for that, and that I think the key API that we expose from the system to let others consume the information from the HCO.